We take another example from the same book, that is from Hogg, McCain and Craig's book, so that we can understand the concept more clearly of the completeness. But before discussing this example, there is a definition which is important to learn and understand. That is, let the random variable z of either it is a continuous or a discrete type and have a probability density function or probability mass function, and if the one member of the family, that is h of z theta, theta belong to its parameter space, the condition that is expected value of u z, the same condition which we have already discussed in the definition of the completeness, that is in that definition we considered that the expected value of g of x, but here that is actually the expected value of u of z, the same actually condition that is equal to 0 for every theta belong to the omega, requires that u of z be the 0 except all those points where the probability is 0. Then the family h z theta, theta belong to its parameter space, is called the complete family of the probability density function or probability mass function. So basically here we consider the one member of that family and we assume the same condition which is given in the definition of the completeness, that is the expected value of u of z is equal to 0, and if we are able to show that it is equal to 0, then it is a complete family. So the example is related to that definition. So first of all, the statement of the example: consider the family of the probability density function, that is h of z theta, that is from 0 to infinity, and here the random variable z has a probability density function in this family is given that 1 over theta e raised to power minus z over theta, 0 less than z less than infinity, show that it is a complete statistic. So here we consider the one member of this family, and that is 1 over theta e raised to power minus z theta, and we are going to show that it is a complete. So how we proceed that? To show that the given family, that is h of z theta is greater than 0. Actually here is also theta, because when we are going to write down in term of family, so that is basically h of z theta basically, and theta is greater than 0. Suppose the random variable z has a PDF in this family is, that is h of z theta, that is basically 1 over theta e raised to power minus z over theta, and it is 0 less than z less than infinity. So actually we have to show that the expected value of u of z, that is actually equal to 0 for any theta, and this implies that u is equal to 0 almost surely. Now we are going to find its expected value. I am going to write directly, that is 1 over theta, ये constant है, ये बाहर निकल जाएगा इंटीग्रल से, and that is from 0 to theta. Sorry, the range of this, that is 0 to theta, not the infinity. The range of this PDF, that is from 0 to theta. So that is from 0 to theta u of z, because we are interested to find the expected value of this. So that is e raised to power minus z over theta dz, and that is equal to 0. So further, this can be written as 0 to theta u of z, and that is e raised to power minus z over theta dz, and that is equal to 0. So you can see that this integral is some sort of Laplace transformation of u of z. So this integral as a form is of the form of Laplace transformation of u of z, and this transformation is useful to convert integral and differential equations into the algebraic equations. So when we are able to convert into the algebraic equations, then the function u of z transforms into a function of theta only, and it is identically equal to 0. So that is basically u of z is equal to 0 for all points. The probability is 0 for all h of z theta which is greater than 0. So the family which is h of z theta is greater than 0 is complete. So by using that definition, we can show that single density is a complete.